This is a talk about AI and the future of software engineering, but also, most importantly, how you can be ready for it. My name's Hywel, and this talk is really at the intersection of two things that I'm very passionate about, AI and tech leadership. So my background in AI really came from being interested in how computer games worked. I ended up doing a master's degree in machine learning and data science, and focusing on AI aspects of that. And then I've been doing some projects in my spare time since then. And tech leadership, I've been a CTO for the last 10 years or so. I've run tech leader dinners in London since 5 years ago, I think now, maybe 6 years. And I also host a podcast for tech leaders. The reason this is becoming a pressing thing that we need to talk about, really a crisis, is the advances are getting faster. This is not a complete timeline. These are just my preferred milestones of the things I think are significant in the history of AI. I think one thing that does feel certain is that big change is coming. The milestones, the big news are happening faster and faster, getting closer together. And now people are starting to talk about things like the end of the software industry. Well, this is something I've been thinking about for about 5 years now. And broadly, if you only take one thing away from this talk, it would be 2 words of advice inspired by one of my favorite books, which are don't panic. I think AI and automation are going to revolutionize the working world, but if you look at past industrial revolutions, there is a pattern that emerges, which should give us reason for hope and optimism. So the first industrial revolution, that was all about machinery and mechanization, and it really affected factories and the agricultural industry. So that meant farm laborers and manufacturers lost their jobs. But actually they were then reskilled to work in factories because all of that machinery, all of those boilers needed people who could make boilers. They needed ironsmiths, they needed mechanics who could maintain all of the equipment. And so what happened was that new, more skilled, more valuable jobs were created that didn't previously exist. In the second industrial revolution, which was really all about mass production and electric power, there was a similar pattern. People lost their jobs. We didn't need the same kind of roles as before, but there was increased demand for labor in factories and more specialized labor in production lines. They were reskilled into new roles that hadn't previously existed. In the third industrial revolution, which was really digital, it was about electronics and computers, the same pattern emerged. Some roles were changed dramatically, like bank tellers were no longer needed as bank tellers after we had ATMs, but they started selling more complicated financial products instead. And an entire new industry was created, like software engineering. The fourth industrial revolution was really about the internet and connecting physical and virtual worlds. And the same thing happened. Some jobs were lost and people were reskilled into roles that couldn't previously have been imagined. And now we're staring at this industrial revolution driven by AI and automation. There's some debate about whether we should consider this a fifth industrial revolution, and some people think that we should can see it as part of the fourth industrial revolution. What we do know for sure is that previously, every time I wanted a picture of a sea otter in the style of Vermeer's Girl with a Pearl Earring, I used to have to commission a skilled artist, but now I can generate one or even many in seconds. We should expect to see the same thing as before. Some jobs will be lost, but people will be reskilled into new, more valuable, more skilled roles. In terms of what that means for a software engineer, LLMs, large language models, seem to be very good at writing code, but not really the rest of a developer's job. And that part, writing code, is about 32% of how developers spend their time. Now, if the coding part gets automated and becomes 10 times faster, we're still going to need all those other functions around it that support the writing of code, but we're going to need them even more because there's going to be more code that's being written, which is going to mean that our people get to spend more time on architecting and restructuring and coordinating work. Essentially, all the more abstract, the deeper, the higher value stuff that they're doing already will become more of the focus. And remember, your competitors are going to be moving faster too. We are still going to have to compete. And so I think we're still going to need big teams to keep up with the competition. We're not going to have fewer people doing more each, because our competitors will have the same number of people doing more and will out-deliver us. Instead, what's going to happen is our expectations from the folks we do have will go up dramatically. And that's partly going to mean that some skills become significantly devalued. The skill of writing code is going to start to trend to be less important. But the rest becomes much more valuable: the skill of architecting, the skill of reviewing code, and the skill of debugging. The speed of change here is likely to be high. Those skills that become irrelevant are going to do so quickly. And there are new skills that will likely be needed, which we can't even predict right now. What that does mean is we know that we'll need to refocus skill sets quickly. Luckily, that is the only crisis that we are facing at the moment. Except no, of course it isn't. We're in the middle of an economic downturn. Roughly 200,000 people have been laid off so far in 2023, and I'm recording this in May. We are under huge pressure to achieve more with less. So, we need to urgently change team skill sets significantly during an economic downturn. I'm going to talk about building versus buying, which will seem unrelated at first, but then I'll come back and explain why it's relevant at the end. So when we talk about build versus buy, we really mean the question of, should we build our own software or our own system, or should we buy someone else's that's ready-made for us? That's rarely a binary decision. For example, with hosting, you can build on premises, you can buy by buying cloud compute, or you can co-locate in server farms, which is kind of in the middle of those options. And even in the cloud, you have a real spectrum of, building your own machines as VMs, or buying just Lambda functions where a lot of the complexity is taken away for you. And when you're making this kind of decision, I think really the process is quite well understood now. There are a load of different factors that we have to consider. I've grouped them into 3 different categories here. We work out the different costs and benefits for each approach, and we pull them all together and calculate what we would typically call the total cost of ownership for each of the approaches that we're considering. I want to draw attention to one here that I think is easily left out, which is variable ROI. Some solutions have extra benefits beyond just meeting the mere functional requirements that you had, and therefore they provide extra value. And I think it's important to capture that in your TCO, your total cost of ownership calculation. So to bring this to life, I want to talk about video conferencing in our product at Hywel. A really key part of what we do is targeted learning that happens live with an expert who's giving feedback and answering questions, which happens via video conferencing. And we had a few different options here. We could build our own video conferencing, we could integrate a third-party solution, or we could ask our learners to split screen with Zoom or some other kind of, cloud VoIP solution. And what we did was to estimate the costs and benefits of each of those options. We thought about the things that were going to be significant to us, estimated the costs and benefits of each of the 3 options, and worked out this total cost of ownership. And for us, the variable ROI was really important here. The mere functional requirements were quite a low bar, but we were conscious that if we could do something that genuinely delighted users, it might make them more likely to stay customers of ours, and indeed to recommend us to other people. And so for us, that variable ROI was a really important factor here. I don't think we talk enough about timescale when it comes to total cost of ownership. But the right decision, the right option to choose, depends on the time horizon that you're optimizing for. So when we were very early as a company, we weren't really looking beyond a single month away. And on that kind of time horizon, by far the most cost-effective thing to do was just ask our learners to split screen with Zoom or Google Meet or something. But as we matured and started thinking about a longer timescale, the ROI for something integrated became more significant. It made sense to integrate a third-party vendor video conferencing solution because of the benefits in delighting users, making something that worked together and just sat perfectly. But of course, if we think about an even longer timescale, if we were optimizing over several years, the payoff for something that was truly delightful and perfect for our needs would be really significant. And so it makes sense for us to build our own. Now that's build versus buy with products and services, which I think is something we're generally very comfortable talking about. we don't really do the same when it comes to skills and capabilities. And I think I know the reason why. We know that individual skills can grow. We have mentors, we have conferences, we have coaches, but we think of team skills as being fixed. And I think that comes because we tell folks to own their own knowledge gaps. We give individuals their own small budget to go and spend on learning and development, and they get to choose their own adventure and follow their passions to some extent. There is no way you will see a team level outcome when you do that. And then when we consider skills, we end up working around the existing people we have, and we buy in those skills through hiring. Really, this is a point about alignment. We talk about alignment a lot as leaders, and for good reason. That the idea is that if everyone is pulling in the right direction, if everyone aligns their velocity with the velocity the company needs to go in, then the company will go faster in that direction. Learning isn't about velocity, it's about acceleration. It's the direction of increase in people's velocity. And we need alignment in acceleration too, which means we need alignment in learning. Because if people are improving in the right direction for the company, then the company's velocity increases in that direction. So how can we go about this? How can we decide when we should be using team level learning and when we should be buying in skills? Maybe you want more productivity in your team, so you want people who are more full stack, so there are fewer handoffs between people in a team. Or you want your individual teams to block each other less, so you want them to become more API driven. Or maybe you just want to move stack, you want to modernize from jQuery into React.js. How can you decide about building skills versus bringing in new people who can already do those things? Well, I'd say there's a lot of factors to consider here. I've grouped them into a few different categories. And this is starting to look very familiar, I think. If you compare it with the systems approach of total cost of ownership and those factors and those costs, you'll see there are similar categories. And in fact, some of the individual costs are almost identical as well. And if we can assign costs for each solution we have for building skills, then we can calculate a total cost of productivity. And this is a good idea. Remember, we typically consider our team skills fixed, and we end up building the organization around what we already have. But the total cost of productivity gives you an antidote to that. It lets you compare the cost of changing those skills with the cost of not changing them. Now, I tried to put together a scenario to kind of play this out. This is based on a 10-person team with some delays due in hiring that you wouldn't see in other areas. I've modeled out the revenue that we would miss out on while we wait for the impact of those skills, and also the opportunity cost of not hiring and therefore being able to do less stuff in parallel. And as you might expect, over 3 years, it's more cost effective to hire people because the extra bandwidth you get pays for itself. But as with total cost of ownership, timescale matters a lot here. You need to know the period that you're optimizing for. In a less stable situation, we probably need to consider a shorter timescale. And if I take the same scenario over 1 year, the reskilling starts to look like the best option. All of which means that we need to take this seriously. This is where build versus buy becomes relevant to AI and the future of work, and also the future of software engineering. Because in a world where AI is rapidly changing which skills are valuable, we should be building the right skills in our existing people. Because hiring for those skills could mean that the skill fit is wrong before people even start their first day of work. And to survive the downturn economy that we're in, we should be optimizing for ROI in the short term, which means growing team skills by building them. So I want to leave you with some questions to consider. Firstly, think about what skills you need in your team and over what timescale you need those skills to be present. Then consider the different options you have for getting those skills. Could your existing team learn it? Maybe you could acquire a company that already does that thing, or maybe you need to build a team and hire people in that already do it. And then for each of those options, consider this total cost of productivity. Look at the different parts of that cost, come up with estimates for them, and think about the timescale you need to optimize for. My opinion is that learning at the team level is now a necessary tool for achieving strategic goals. It will let you grow during a downturn, and it will keep your organization ahead of the disruption from AI. And if you try this process, if you try this total cost of productivity and determine that you need to build skills, then please do get in touch with us at Hywel. I'm one of the founders, and we built this company to help solve this exact problem. But honestly, we're also just very interested to hear from people and hear their perspectives on AI and on building skills in their teams. Thanks for your attention.